Hello everyone, I'm Daniel Chen. Now we're going to introduce you the Hoperf's sensor products. Based on how pressure is measured, pressure sensors mainly fall into three categories: absolute pressure sensors, gauge pressure sensors, and differential pressure sensors. Absolute pressure is measured relative to a perfect vacuum, which is 0 kPa, so absolute pressure values are always positive. Gauge pressure is measured relative to the ambient atmospheric pressure. The standard atmospheric pressure is 1713.25 hPa. This value can be either positive or negative. Differential pressure is the pressure difference between two pressure sources. This value can also be positive or negative. Based on how the internal MEMS element works, pressure sensors can be further divided into two types: piezoresistive and capacitive. Piezoresistive type. A resistive Wheatstone bridge is etched onto the pressure diaphragm. When the diaphragm is mechanically deformed by external pressure, the output signal from the Wheatstone bridge changes accordingly. Because the temperature response of a piezoresistive sensor is non-linear, temperature compensation and pressure calibration are usually required. Also, piezoresistive pressure sensors aren't ideal for applications that demand low pressure noise, fast transient response, good high temperature stability, or low power consumption. Capacitive type, a capacitive Wheatstone bridge made up of a reference capacitor and a variable capacitor is etched onto the pressure diaphragm. When the diaphragm is deformed by external pressure, the output signal from the bridge changes. Since pressure measurement is done by comparing the difference between the sensing element and the reference element, capacitive pressure sensors offer better temperature stability and lower pressure noise. Compared to piezoresistive sensors, capacitive pressure sensors have lower pressure noise, higher pressure measurement accuracy, and lower power consumption. They perform especially well in motion tracking applications. The internal structure of a pressure sensor mainly consists of the following parts: a PCB substrate, an ASIC component, a MEMS component, bonding wires, and a housing. After the pressure sensor is packaged, it goes through calibration, testing, and packaging, in that order before it can be shipped out to customers for use. Now let's take a look at some typical applications of these sensors. With the use of pressure sensors and temperature humidity sensors, a portable weather station can monitor and record various weather parameters in real time. Things like temperature, humidity, air pressure, wind speed, wind direction, and rainfall. Recommended products: HP203N and TH09C. Using a pressure sensor, a barometer can continuously monitor atmospheric pressure and then calculate altitude or sea level pressure based on the measured value and the reference value. Recommended product HP303B. In sports and fitness, pressure sensors can be used to accurately measure small changes in altitude. For example, the up and down distance when doing a pull-up or a push-up. Recommended product HP303S. In outdoor sports such as hiking, running, cycling, swimming, surfing, diving, and mountaineering, it's crucial to keep a close eye on altitude changes, weather changes, direction of travel, and dive depths. That's why wearable devices really need to come standard with ABC sensors, altimeter, barometer, and compass. Recommended product HPS27W. During free fall, pressure increases significantly and the change in pressure is proportional to the change in height. You can estimate the height change by dividing the pressure change value by 12 pascals per meter. If the pressure sensor has high resolution and high-speed measurement capability, it can accurately detect the exact moment the free fall begins. Then, by comparing the pressure difference before and after the free fall, you can calculate the height change during the fall. Recommended product HP303B. In indoor positioning and outdoor navigation, especially in GPS-denied indoor environments, accurate altitude detection can help with personnel localization. By integrating a pressure sensor, smart devices can provide additional floor-level information, which helps rescue teams save more lives in time. Recommended product HP303S. For drone altitude hold applications, using a pressure sensor to monitor altitude in real time allows for precise control of the drone's flight height. Recommended product HP303S. To ensure safe and efficient operation, a smart window cleaning robot needs to monitor pressure changes in real time and adjust dynamically to changes in the external environment. By integrating a pressure sensor to continuously monitor suction changes, the system can automatically trigger safety mechanisms, such as automatically stopping or resetting its position as soon as it detects an abnormal pressure. This effectively prevents the robot from becoming unbalanced or falling due to external forces. Recommended products HP203N or HP303B. In ultrasonic gas meter applications, integrating an air pressure sensor to monitor real-time changes in gas pressure and temperature enables temperature and pressure compensation. This effectively solves the measurement error problems that traditional mechanical gas meters suffer from due to temperature and pressure fluctuations, helping gas companies close the gap between gas supply and sales volume. Recommended product 6A62I. By integrating a temperature and humidity sensor, a smart thermostat can compare the indoor temperature with the set point in real time and automatically control the fan of the air conditioning terminal, the motorized valve or air valve, and the on-off state of heating or cooling equipment. This achieves a dual improvement in both comfort and energy efficiency. Recommended product TH09C. Now, let me introduce 4 typical non-waterproof absolute pressure sensors from Hoperf. HP203N piezoresistive package size 3.6 by 3.8 by 1.15 mm, pressure range 30 to 120 kPa, pressure accuracy plus or minus 200 pascals. HPS 700AZM piezoresistive, package size 3.6 by 3.8 by 1.1 mm, pressure range 0 to 1/1600 kPa, pressure accuracy plus or minus 2 kPa. HP303B, capacitive, package size 3.6 x 3.8 x 1.15 mm, pressure range 30 to 120 kPa, pressure accuracy plus or minus 100 pascals. HP303S, capacitive, package size 2.0 by 2.5 by 0.95 mm, pressure range 30 to 120 kilopascals, pressure accuracy plus or minus 100 pascals. Now, here are 5 typical waterproof absolute pressure sensors from Hoperf. HP206N, piezoresistive, package size 6.2 by 6.8 by 3.1 mm, pressure range 30 to 200 pascals. Pressure accuracy plus or minus 200 pascals. HP206W piezoresistive package size 6.2 by 6.8 by 3.1 millimeters. Pressure range 30 to 200 kilopascals. Pressure accuracy plus or minus 200 pascals. HP5834 piezoresistive. Package size 4.5 by 4.5 by 3 millimeters. Pressure range 0 to 1200 kilopascals. Pressure accuracy plus or minus 200 pascals. 6862I capacitive. Package size 6.2 by 6.8 by 3.1 millimeters. Pressure range 30 to 120 kilopascals. Pressure accuracy plus or minus 100 pascals. HPS27W capacitive. Package size 2.7 by 2.7 by 1.7 millimeters. Pressure range 30 to 120 kilopascals. Pressure accuracy plus or minus 100 pascals. Now, here are two typical gauge pressure sensors from Hoperf. HP209 piezoresistive, package size 9.0 by 9.0 by 11.3 millimeters. Pressure range 0 to 200 kilopascals. Pressure accuracy plus or minus 1.0% Fs. HPSXXGS piezoresistive, package size 10.6 by 7.0 by 10.0 millimeters. Pressure range minus 100 to plus 200 kilopascals. Pressure accuracy plus or minus 1.0% Fs. Now here are two typical temperature and humidity sensors from Hoperf. T09 temperature sensor, package size 1.495 by 1.025 by 16 millimeters. Temperature range minus 40 to plus 125 degrees Celsius. Temperature accuracy plus or minus 0.2 degrees Celsius at minus 10 to plus 65 degrees Celsius. DH9C temperature and humidity sensor, package size 2.0 by 2.0 by 0.75 millimeters. Temperature range minus 40 to plus 100 degrees Celsius. Temperature accuracy plus or minus 0.15 degrees Celsius at 0 to plus 70 degrees Celsius. Humidity accuracy plus or minus 2% RH at 0 to plus 85% RH. Finally, let me summarize the advantages of choosing Hoperf's sensor products. Over 20 years of experience in sensor product design, development, and testing, a wide range of evaluation and development tools available, fast response, technical support, continuous investment in new product development, helping customers shorten their products' time to market. Thank you so much for watching.